Okay, here's another example of proof by contraposition. For any integer m, if m squared is odd, then m is odd. Okay, so put your video on hold and write it in symbols. Okay, here it is written in symbols. For all integers m, if m squared is odd, then m is odd. So now whenever you have a proposition that's conditional, you should always ask yourself the question, should I do a direct proof or a proof by contraposition or maybe even a proof by contradiction? In this case, if you try to do a direct proof, you'd start by saying let m be an integer, suppose m squared is odd. Well, then you would use the working definition of odd to write m squared as 2k plus 1 for some integer k. And then you'd have to deduce somehow that m is odd. And in order to do that, you'd have to take a square root to get from m squared back to m. And you can't say much about the square root of something in the form 2k plus 1. So that's not a very good way to proceed. But on the other hand, if you use proof by contraposition, you would start with giving yourself an m, an integer m, and you would then assume instead that m is not odd, which is to say m is even. So you could write m in the form 2k for some integer k, and then your task would be to prove that m squared is not odd. In other words, to prove that m squared is even. And all of a sudden, everything seems very simple. So I think that's the way to go. And so what I want you to do is put your video on hold, do some calculations to get an overall feel for what the proof should look like, and then use those calculations to build a correct proof. And when you come back, you can compare your proof to mine. Here's my proof, but let me show you first the calculations I did in order to get it. We started off by assuming m is even, so I wrote it in this form. Then I squared it, both sides, because I knew that I had to make a statement about m squared. And then I realized that I wanted to show that this thing was even, and so I factored a 2 out of it. That left me with a factor of 2k squared, which I know to be an integer, and therefore by definition this is even, and so that gave me the result. So building that up into a proof, looking back at the symbols, I started off by saying let m be an integer. Then I warned you that I was going to argue by contraposition. So I said suppose that m is even. Then m can be written in this form for some integer k. You must remember to put the quantifiers in. Squaring both sides gives this, which can be rewritten as this. And since this bit is an integer, it follows that m squared is even. This completes the proof.